Hi, so thanks for coming. My name is Alexandre Lebrun, and I'm the founder and CEO of Wit.AI. And I'd like to speak today about speech interface, so Siri-like interfaces for the Internet of Things. So I spent the last 12 years trying to build machines that you can talk to. First in an enterprise model with a company called Virtuos that was acquired 2 years ago by Nuance Communications, and more recently with Wit.AI. And so Wit.AI is a platform that makes it very easy for developers to add a Siri-like interface to their app or to their device. So just one word, actually, it's an API, and you can stream audio to the API, and you will get JSON in return with actionable data that you can use to trigger actions in your app or in your device. So humans have been fascinated with talking machines for a very, very long time. And already with the Greeks, they had a god like Hephaestus, which was the god of hackers of the time, blacksmiths, craftsmen. And this god was supposed to be able to build a machine that could talk. Most recently, I could call him the god of computer scientists today, at least mine, Alan Turing, in 1950, when he tried to answer the question if machines can think, if machines are intelligent. His answer is a very famous Turing test. And basically what he says is, if a machine can talk with you for 5 minutes and you don't know it's a machine, but you think it's a human, then this machine must be a thinking machine. This machine can be intelligent. So it's very interesting because he defined intelligence as the capacity to manage a conversation, to talk with you. And then after that, scientists became obsessed with this problem, to pass the Turing test. And in '66, at the MIT, Joseph Weizenbaum built ELIZA, which is a very simple program. You can still run it today. That is able to chat with you. So actually, you type. So it's a virtual psychanalyst. So you can talk about your problems, your issues, why you don't sleep well, and it will answer and manage this chat with you. So it was meant to be a game or not something serious, but it was very, very popular, and then Hollywood loved this thing where machines can talk and think and become smarter than humans. And of course, this is HAL 9000 in the Space Odyssey in '68. You might remember that HAL decided to kill the humans in the spaceship. After that, talking machines were everywhere in movies. You might remember KITT, which is from 1980. So actually, KITT is like Google self-driving car meets Siri. It can drive alone and it can talk with Michael. So it's interesting because if you compare Google self-driving cars today, it's almost KITT. It's almost as smart. They can drive anywhere alone without any human intervention. But if you compare Siri to what KITT is supposed to be able to do in terms of understanding and talking with Michael, Siri is really, really far behind, and we are not at all close to what was described in this series. If you type voice commands for cars in YouTube or on the net, you probably find something like that.
Media.
Radio.
Nej. Icon, sång, media.
Radio.
Nej. Playlist.
TV.
Nej.
This device is not available.
I'm not going to turn on my TV. I'm going to play music. Music.
You can operate many functions of the MMI quickly and easily with the speech dialogue system. You can interrupt the speech dialogue at any time by pressing the talk button on the steering wheel to enter a command. You can say,
I am
cancel at
commanding
any
you to
time.
shut up.
Press and hold the talk button.
Shut up!
Navigation.
Nej! I hate you!
Radio.
Nej!
So it goes on and on, but we don't have lots of time. But it's interesting to see what
Car,
and
voice
you know,
control systems.
if you
I've looked around and I never met anybody who was happy with that. So it's very far away from Kit and Michael relationship. Sorry. In the real world today, the three areas where speech is the most deployed, the speech interfaces are most deployed, are IVR, call centers, and I'm sure nobody in the world likes to talk to a machine with a call center. It's in cars, and we've seen the result. And more recently, on smartphones with the Siri, Google Now, or Cortana kind of virtual agents. And it's interesting to note that here in San Francisco, you might say, yeah, everybody uses Siri, but if you look at the number, like 5%, about 5% of iPhone owners actually use Siri. So it's still a very, very small proportion of users. So people are not really happy with that. So the question is, why is it so difficult to build a speech interface? The first reason is it's a very, very hard AI problem. You have to manage noise, background noise. You have to manage accent, like my French accent. Millions of ways to say the same thing. The context, the common sense. When we speak together as human, we rely a lot of common sense knowledge, and so we just say what's absolutely necessary. Speech is very, very efficient. It's a very efficient compression algorithm. But for machines, it's extremely difficult to get this. And so you need to do all that. It's a long chain from going from speech to text and to text to meaning, then reasoning to decide about the next action, then generate a text response, and then from that generate speech that you can send back to the user. And if any of these steps breaks, then everything breaks, and it's a terrible user experience for the user. So that's very difficult. The second reason is you have two categories of users around you. So people who tried speech interfaces, like the guy on the Audi video, they will never try again. They say, no, I tried it a long time ago, it didn't work, it just doesn't work. So these users don't even want to try again. And then you have the other category who never tried and who have, because they've seen Kit and Space Odyssey and everything, have totally unrealistic expectations. And so, for instance, if I ask my mother to ask a question to Siri, she would ask a crazy question about philosophy or whatever, because she just asked a question, so she doesn't know the limit of this. So it's very hard to build something for these two categories of users. And then the third reason, and I think the biggest difficulty is, unlike many objects we've been using since the beginning of humanity, a speech interface doesn't communicate about what it can do or cannot do. So if you look at a hammer, okay, you see the hammer, you see the handle, and you know what you can do with that. You won't ask a question to your hammer or try to cook food with it. So the shape of the object communicates about what you can do with it. If you look at the window GUI, this is the same. I see file, folders, a trash. I know that there is a menu. A menu is nothing else than a list of possible actions. So it's very, very simple. It tells me what I can do. An ATM is the same. On a bank ATM, you have 3 buttons. This is the 3 things you can do, and that's very simple. If you go to a Starbucks and you see this woman, you won't ask a question about how many atoms are there in the universe, or you might try, but if she can answer, you'll be happily surprised. You won't be upset if she cannot, because it communicates, okay, I can do coffee for you, that's it. But if you look at HAL or even Siri, you have a microphone, what is the limit? What is the scope? What kind of question can it answer or not? It's not in the shape of the object. And so it's totally new for us. And this is the biggest problem when we design this kind of interface. So, and yet we have to find a solution, because as we shift to the Internet of Things, to these smart devices, we have no screens anymore. We have no keyboard. Many devices won't even have a small touchscreen. So where speech used to be a nice to have, and it's very clear that on an iPhone, Siri or a speech interface is really nice to have. You can show your friends, play with it, but you could live without it. But on a smartwatch or on Google Glass, for instance, you cannot live without a speech interface. So for these things, we really need to build good speech interfaces, and that's new. Many people predict that there will be 10 billion voice-first devices in a few years, and so as developers, we will have to build millions of apps for these devices, and so our apps will have to have a speech interface. So we better find a good solution to do that. So the good news is there are new things. There is hope. The first one is I mentioned that a microphone doesn't communicate about what you can do with it, but actually most of the smart devices, wearables, or home automation systems do communicate about what you can do with them. If you look at a Nest thermostat, you won't ask the question about how many atoms there are in the universe. You know it's a thermostat, you can change the temperature, maybe ask about the weather, and that's it. So these devices are small and everywhere, but each device has a very, very clear scope that the user understands. And so that's a very, it helps a lot when you want to do a speech interface for that, because the scope is well defined. The second thing is that in the last 2 or 3 years, a major breakthrough were achieved in speech recognition accuracy, owing to deep neural networks. So I'm sure you're familiar, but neural nets were kind of abandoned in the 80s because somebody said, no, it doesn't work after all. And a few guys, especially Geoffrey Hinton and Yann LeCun, so there are academics, continue to work on that. And a few years ago, suddenly, owing to more processing power, new approaches, more data, they found deep neural nets, something wonderful, and it suddenly the word error rate, that this is a metric we use to measure the performance of a speech recognition engine, dropped about 12% in a few months when they started to use deep neural nets for speech recognition. So now Hinton and LeCun are very well. They are working at Google and Facebook, respectively. And so it was a big breakthrough. And the last thing is we started to say, okay, natural language, speech are a very hard problem. So instead of working each company on their own application, speech engine, and so on, let's put data in common. Let's use open source approaches. Let's build a community to solve it. And so this is exactly what Wit.AI is trying to do. And it makes a big difference because we can get much more data when we join forces like that. I like to give a few best practices from my own experience building speech interfaces. The first is, the most important is to define a very, very reasonable and small scope when you start. You cannot build Siri overnight, but if you have a device or an app that does one thing and you want to build a few commands for that, it's possible. But you have to start by defining this very, very clearly. And you shouldn't have crazy expectations, especially if you have lots of background noise, like when you drive a car, or if you have a bad, low quality microphone, if the user is very far away from the microphone, like in a home automation system, it makes speech recognition extremely hard. So depending on these parameters, you can be more or less ambitious for the scope for you want to do Siri or more than Siri or just a few commands. And finally, you can have cloud speech processing. Most systems today are actually use the cloud. That's why Siri cannot work or Google now don't work when you lose your network connection. It's possible to do embedded processing, but then you have to lower your expectations because with a small device, it's very hard. There is not enough processing power to do good processing. The second thing is communicate to the end user about what your speech interface can do or not. As we saw for something like a Nest thermostat, this is obvious, but for other apps, it's not obvious. So you have to find good ways to communicate about that. And so, for instance, this is a university project with a barista bot. So it can actually do coffee for you. You can ask for very complex, wet latte with soy milk and hazelnut, anything. So it will actually do this coffee for you, but from the shape and you see the coffee. And everything you understand the scope. So it's an example. It's easier with robots. So the first thing is you shouldn't expect your users to learn how to talk to your interface. You shouldn't expect your user to adapt to your system. You have to adapt to your users. And a good example, a counter example, is the Palm Pilot user manual. And you might remember that you had to relearn how to write to write on your Palm Pilot. And it's crazy, I think, to ask users okay, my machine is like that, and you have to learn or just leave, I don't care about you. You cannot ask this to your users. In speech, we have a very good approach called Wizard of Oz, and it means that when you launch, you actually have humans listening to the commands and answering. So the user thinks it's the machine, but it's done by humans. And you use this to learn what people say, how they say it, what they expect, and you actually build your system from that. So it's instead of first building it and then putting it in front of users, and you use that to continuously learn and always adapt to the user. So analytics are very important to understand what user actually want to do. So this kind of it's a now robot from Aldebaran. And there is a speech interface, and it can do many things, and everything was learned from bottom up, from actual usage. And the last thing is, the best speech interface sometimes is no speech interface, and very often in history, when there was a shift from one paradigm to another one, we just tried to do the same thing as before with the new thing. So, for instance. 100 years ago, when people started to think, okay, let's build a washing machine to wash clothes. If you look at the very first research, they did a kind of robot that was squatting in front of a bucket and scrubbing clothes on a board. And we do this every day. We just say, okay, let's take the user interface from before and put it on the new kind of device. So, for instance, you see many home automation systems where people have a command to say turn on the light, but you don't need that. If the system knows that you are back home and that it's dark, they should turn on the lights. You don't have to ask. So before, it shouldn't be just pulling information, but the system might be proactive and reduce by 50% the number of requests that the user has to do. To the system, and it makes very, very good user experiences. So we think, a few people think that we will. I don't know if you saw the movie Her, but many people think that we will arrive at this stage where most devices might be just an earbud, and you don't have keyboards anymore. You don't. Everything is voice-based, audio-based, and recently, Motorola release a moto hint, which is very close to what they use in the movie Her. We think we will arrive at this stage in 5, 10, or 15 years, and so speech interface really will become ubiquitous. So thanks very much for your, thanks very much, and if you have any question, I'm happy to answer. Yeah, so you say if somebody's sleeping and I come home and it's dark, the system should not turn on the lights. But in this case, I would say don't turn on the lights because by default they should turn on the lights. So yeah, it's a good example. But in many situations, actually, you don't need to say anything if the system can get enough information from other devices for enough context. It's easy to perform the action without any command. Yeah. Yeah, absolutely. It's called speaker ID or speaker authentication, and so it's a well-resolved problem today. We know who is speaking, and so you can leverage this information.
When conducting a wizard of Oz study, how do you address the fact that you'll inherently be guiding users towards using certain vocabulary?
So actually you don't, because in Wizard of Oz, users can say anything they want, and a human.
If the thing that you're trying to get at is something like turn on the lights, then what do you present to a user in order to get them to ask that kind of question?
So actually it's another problem. Yeah, you have to communicate before they start to talk about what they can say, and you have to find the balance between setting expectations and if you do it too much, it won't work. Because you will fall in the pilot problems where you teach your users to do something. So it's a very hard, and when you have lots of experience doing it, you find the right scope, the right opening, but it's difficult. Yeah.
It's an awesome list of best practices for audio-based interfaces. Have you looked into like mixed modal interfaces at all?
Yeah, we are very, very interested in interfaces that mix gesture with some things like Mayo or Raspberry and voice, and I really think this is the future. Many startups, I like today is very exciting because many startups are each working on one channel, one mode, and I think the perfect applications will mix these modes. Yeah.
Is Wit on iOS processing on the device itself?
No, right now it's streaming on our iOS SDK, streams the audio to Wit.AI. And so it's not a local, so we're working on the embeddable runtime. We hope to release it early next year, but it's not, right now it's cloud-based.
And then on Android, you're not using the same server, you're using the Google Voice Engine?
No, we do the same as on iOS now. We don't use Google Speech-to-Text API on Android because you cannot customize it. You cannot add vocabulary, you cannot provide a language model to help the engine to better understand what you say. So we just bypass the Android speech-to-text.
Do you use teaching algorithms to accustom the voice API to the voice or manual or whatever?
Yeah, so actually, I had no time to speak more about Wit.AI, but it's exactly what Wit does. Very similar to Prediction.io, but that we saw before, but specialized for speech. So in Wit, you have an analytics dashboard called the inbox, where you see what Wit did, so what input you got, and how Wit processed them, and you can validate, dismiss, edit this, and we use this feedback to train better model for your app. So we train a statistical model for each app. Each app has different customized models. So for speech and for natural language understanding, the layer on top of speech. And so the more you use it, and we have users with very strong accents like me, and after a while, it starts to pick up. And if you combine this with a speaker ID, Wit knows it's me, and will select the right models and work better. And so very importantly, on Wit, so for almost 5,000 developers use Wit.AI now, and most of them agree to share the data. So we learn from every app, and we put this learning in common. And so when you use Wit, you benefit from these learnings. So you can sign up on Wit.AI. It's free. You can use your GitHub account, and you can try it in a few minutes if you want to discover. I think we are okay. Thank you.